Chapter 8, Subnetting IP Networks. Designing, Implementing, Managing, and Effective. IP address plan user that networks can operate effectively and efficiently. This is especially true as the number of host connection to a network increases. Understanding the structure of IP address and how to modify in order to more efficiently meet routing requirements is an important part of planning IP addressing scheme. In original IPv4 address, there are two labels of hierarchy, a network and a host. These two levels of addressing allowed for basic groupings that facilitate in routing packets to a destination network. A router forwards packet based on the network portion of an IP address. When the network is located, the host portion of the address allows for the identification of the destination device. However, as a network grows, with many organizations adding hundreds and even thousands of hosts to their network, the two level of hierarchy is inefficient. Subdividing a network adds a level to the network hierarchy, creating in essence three levels a network, a subnetwork, and a host. Introducing this additional level to the hierarchy creates additional subgroups with an IP networks that facilitates faster packet delivery and added filtration by helping to minimize local traffic. This chapter examines in detail the creation of assignment of IP networks and subnetwork addresses through the use of subnet mask. The process of segmenting a network by dividing it into multiple smaller network spaces is called subnetting. Every network address has valid range of host address. All devices attached to the same network will have an IPv4 host address for the networks and common subnet mask or network prefix. Traffic can be provided between hosts directly if they are on the same subnet. Traffic cannot be provided between subnet without the use of router. To determine if traffic is local or remote, the router is used the subnet mask. The prefix and the subnet mask are different ways of representing the same thing, the network portion of address. IPv4 subnets are created by using one or more of the host bits as network bits. Two very important factors that will lead to the determination of IP address block with the subnet mask are the number of subnet requires and maximum number of hosts needed. Pre-subnet. There is inverse relationship between the number of subnet and the number of hosts. The more bits are borrowed to the create subnet and fewer host bits are available. Therefore, there are fewer hosts per subnet. The formula is 2 raised n where when n is the number of host bits remaining. It's used to calculate how many addresses will be available in each subnet. However, the network address and broadcast address within the range are not usable. Therefore, to calculate the usable number of addresses, the calculation is 2 raised to n minus 2 is required. Subnetting a subnet or use variable length of subnet mask was designed to avoid wasting addresses. IPv6 subnetting requires a different approach than IPv6 subnet. An IPv6 address space is not subnetted to conserve addresses. Rather, it is subnetted to support hierarchically logical design of networks. So while IPv4 subnetting is about managing the address IPv6 subnetting is about building and addressing hierarchy based on the number of routers and networks they support. Careful planning is required to make best use the available address space. Size, location, use, access, requirements are all consideration in the addressing plan process. After it's implemented, an IP network needs to be tested to verify its connectivity and operationally perform. When two or more switches are connected together, the size of broadcast domain is increased, and so the number of collision domains. The numbers of broadcast domain is increased only when routers are added. A router is used to route traffic between different networks. Broadcast traffic is not permitted to cross the router and therefore will be contained within the respective subnet where it originated. Two reasons for creating subnets include reduction of overall network traffic and improvement of network performance. Subnets also allows an administrator to implement subnet-based security policies. The number of routers or switches is not affected. Subnet do not simply network design. The largest subnet in topology has 100 hosts in it, so the subnet must have at least 7 host bits. In it, 2.5 to 255.255.255.0 has 8 host bits, but this not have meet the requirement of providing maximum number of subnet. Each network that is directly connected to interface or on a router requires its own subnet. The formula is 2n, where n is the number of bits borrowed used to calculate the available numbers of subnet when borrowing a specific number of bits. The network version or prefix of IPv6 address is identified through the prefix length. A 64 bits prefix length indicates that the first 64 bits of the IPv6 addresses is the network portion. Hence, the prefix is 200 DB8 BC15A. DHCP is generally preferred method of assigning IP addresses on a host large network because it reduces the burden on network support staff and virtually eliminates entry errors. However, DHCP itself does not discriminate between authorized and unauthorized devices and will assign configuration parameters to all requesting devices. DHCP services are usually configured to assign address from the subnet range, so there is no guarantee that every device that has need an address will get one. If the block addresses allocated to the pole is 192.168.10.0 bits 24, there are 254 IP addresses to be assigned to hosts in a network. As there are three printers which need to have their address and assigned statistically, then there are 251 IP addresses left for assignment. When monitoring server, our network administrators need to be able to quickly identify them using predictable static addressing scheme for this device make them easier to identify. Server security redundancy duplication addresses are not featured of IP address scheme. The network of IP address 192.169.5.0 with subnet mask of 255.255.255.224 provides 30 usable IP address for each subnet. Subnet A needs 30 host addresses. There are no addresses wasted. Subnet B uses 2 of the 30 available IP addresses because it's serial link. Consequently, it was waste 28 addresses. Likewise, subnet C wastes 28 addresses. Subnet D needs 40 addresses, so it wastes 60 addresses. The total wasted addresses are 0 plus 28 plus 28 plus 16 is equals to 72 addresses.